you can see the goal is that we're going to figure out the area of the triangle. You guys over at the round table might want to move to the back table so I'm not standing in front of you if you need to. But you should be able to find the area of the triangle with grid paper, which you've done. We're going to review that, and without grid paper, with the rules. We're going to review the rules and why they work. Okay? So, like on this triangle from last week, if I wanted to figure out the area of this triangle here in example 1, right here, what was the strategy we were using to figure out the area of the triangles? Okay, Andrew?
We drew a box.
Yeah, we drew a box around it, right? Like that. Okay? So, and then we found the area of the box, right? So, Emma, what's the area of that box? It's a square. Right. And you can see that because this height is 3 and the width is 3. And 3 times 3 makes the 9 squares that are hidden, right? And the triangle is only half of that square. So the triangle is just 3 times 3. So this is the triangle area. A little triangle there so you know which one. And then after we do that, we divide by 2. So we could write that as 9 divided by 2. So one thing I was telling the morning class, especially kids that have a little trouble dividing bigger numbers in half, like odd numbers, take 9, just think of 9 as 8 plus 1. Works all the time. Half of 8 is 4. Half of 1 is a half. So add those together. And the area of your triangle is 4.5 square units. And we could write centimeters squared because it's a centimeter grid paper. Raise your hand if that makes sense. So everybody's comfortable with that one because of the shape, right? Some of the shapes aren't as easy. So the second one, can I still surround that?
Yeah.
How would you describe the way the box would go, Walter?
Well, if you kind of roll over.
Oh, you could do that. Let's stay with rectangles.
Oh, well, should I draw it?
Yeah, you can draw it. Right. So it's basically this rectangle right there, right? Julian.
The area that's not shaded on the outside.
Right.
Box fit into the area.
Exactly. So basically, if we had a symmetry line here, a line that divides the shape into equal congruent parts, you could see that this area 1 is the exact same as this area. And this area here is the exact same thing as that area, right? So the inside, this whole thing, is half of the whole rectangle, and the rectangle is a 3 by what? 5. So the area of this triangle is 15 divided by 2, though, right? Because it's only the triangle. So that's 7.5. And the units are centimeters squared. Still, those triangles still look pretty easy, right? You can put a nice box around them. Okay, so what happens when your triangle looks like this example 3? Can I put a box around it?
Yeah.
And without a parallelogram? Yeah. Okay, how would you do it, Lori? Lexi. Oh.
So,
Called your big sister. Where would you start? If I labeled my points A, B, and C.
So you would do like point B to point C, and then like put a 3 by 3 box around that.
Even bigger. So you could, can you get the whole thing with one box?
Yeah.
Can you figure, where would you start now?
You would do A to where C is but like one box.
Straight down, right?
Yeah, and then to B.
Straight over.
And then back up to A.
Straight up.
And then
Right. So it's, the question is the triangle half of that box? No. But can we figure out the area of the triangle?
Yeah.
Yeah, Mark. And that's what we're going to get to in a minute. Exactly. So he's saying that if, for example, in this back here, we didn't really need the box, although the box makes it helpful. Because we could just take how much is the base, as long as you know where that is, and sometimes you don't, and how much is the height, as long as those form what we would say is a right angle. So if I got rid of the red, let me draw that again, and looked at my crayon. Oh, what happened to all my colors? Oh, look at this number here versus that number there. That would work in this picture too. So if I looked at the box, it's also true that I really just used this value and that symmetry line, didn't I? In this case, it was a symmetry line because that made this nice straight square angle, the right angle, okay? So we're going to come back to that, but first let's look at this box. What's the area of that box?
16.
16. Does everybody see that? So now we're not dividing in half. We're going to do that subtraction thing that we did last week with one of those homework problems. Can you figure out the area of this triangle out here? That little space? Somebody new. Ryan, you want to try?
6.
So it's 4 units high, but this takes up how much? Like if I move that triangle out of the picture, I didn't get all of it. There we go. If I take that triangle, can you see that it's half of 4 units?
Yeah.
So how much is that triangle? If it's half of 4 units. Do you see that?
Yeah.
Okay. Can you guys see that? The other one is 8. Right. So I don't know if you guys see where he got the 8 from, but do you see this triangle? So if I take that triangle out of the picture for a minute, can you see it's half of 16? Which is 8, right? So you could do 16 take away 2. I had the highlighter. 16 take away 2, take away 8, right?
6.
Right, because 16 take away 2 is 14. Take away 8 is 6. So we say this is 6 centimeters squared. So look at what Mark was trying to explain. Okay, if we look at what Mark was talking about, he's saying you don't really need to look at the box. You could just look at the base of the triangle. Well, what else do you need to look at? The height. And where is the height? Ellie, do you know where the height is?
It's from the base of the highest point.
Yeah, or from the highest point of the triangle down to wherever the base lines up with. You know what I mean? Like, to see how tall something is, you would go from the top to think of the base of the triangle as the ground. You see that? And then you make that nice, you see there's that nice square angle there. So even if, let me go away so I can come back without the shading. I had a little trick there to have that shading in there. Even if I didn't have all this other stuff, Okay, and I just looked at just this triangle now. The base is 3 units. This is the height because it makes a right angle with what we would say the ground. Even though it doesn't touch the base, it makes a nice square angle with the ground. So that's how high, we would say that's how high the triangle is. We always imagine that the height of something is measured at a right angle. And that's 1, 2, 3, 4 units. Okay? So if I take those, just those two numbers, I do the area of the triangle is the base, which is 3, times the height, which is 4, and I divide it by 2. So what's 3 times 4? 12. By 12 by 2, you get 6 centimeters squared without that rectangle. That make sense?
Yeah.
Okay, so let's take that. Oh, there we go. I'm going to just move that over here for this one. Okay? Where'd that come from? I moved it by accident. That was the hidden rectangle that was the square that was there. If I turn the page, it goes away. Let's try to capture attention today by making those sort of appear. So let's do the rectangle approach here. Everybody now probably knows I can draw a rectangle around any triangle. So there's a rectangle. And let's see, Olivia, what's the area of that rectangle? What's this length? 3. And this is 6, right? So the area of the rectangle is 18, right? But if I want the area of the triangle, I have to divide my 18 into half in this picture because can you see the symmetry line here? This is the same as that, and this is the same as that. So the area would be 9 square units. But if I used Mark's method, and I just look for the base, that's right here. You see the base? And the height is wherever you could draw from the top point to form a right angle with the ground. And so the height, you can see that height is the same, isn't it, as the side of the rectangle? So it's just the base times the height. And then what do I have to do? Yeah. I don't, because I didn't actually. I could, but that's a lot more work. Like, let's get rid of that yellow. Okay, so here, if we just look at this without the rectangle, and you see a triangle, if you can identify the base, I'm highlighting it so you guys can see what I'm talking about. That's the base, in this case. And then the height, you would have either inside the triangle, the height could be outside the triangle if the triangle is slanted, tipped over like this one. But the height has to make a right angle with what I'm calling the ground, basically, the where the base is. Now, since this is 3 units and this was 6 units, I treated it as one triangle. I could have treated it as 2 triangles, but it's more work and you don't always know. Like, you didn't, in this case, we know this part's 4 and this part's 2, so I could have done 2 triangles because what's 6? So instead of using the 6, I could have used the 4 and the 2. What's 4 times 3? And then the half of 12 is, so this part would be 6. And what's 3 times 2? And half of 6 is 3. And if I add 6 and 3 together, I get 9. But I didn't need to do that. And so the reason you want to know that you don't have to do that is sometimes you have, let's bring in just some other pictures. If I had just some triangle that I made up, where you don't have that information and you have some information. So maybe you have, let's say this is 30 and this is 13, and maybe this is about 35, and then you also have this drawn in like that at a right angle, and you have that this is 12. With a picture like that now, you should be able to find the perimeter, and you should be able to find the area. So for the perimeter, you basically only look at the numbers where? On the outside, right? On the rim, right? So we would do 35 plus 30 plus 13. And let's say these are all also centimeters. So we'd have 35 plus 30 plus 13. So what's 35 and 30? So 65 plus 13. What's 65 and 10?
75.
75, add 3 more.
78.
So 78 centimeters. Now for the area, even if the box rectangle isn't there, you could use the property where you find the base. So that's right here. And then the height is the piece that's making that square angle with the base. So the square angle is right here. Do you see it?
Yeah.
So to find the area, you would just do the base, which is 30, times it by the height, which is 12. It's the number, it's how tall the triangle is. And then you take that and you divide it by 2. So what's 3 times 12? What is it?
36.
So 30 times 12 is 360. Divide that in half. What's half of 36? 18, so 180, right? And it's centimeters squared. So I think the trick is figuring out what the height is. So for this triangle, can you see the height is just from the base basically to whatever would line up with the top of the triangle. A lot of times you'll see the height inside the triangle, but you might see the height sometimes out like that. They may show it out like this, where they sometimes they'll extend and show it out like that, but usually they show it inside. But did you notice that didn't change? It's still the height. So the rule for triangle area is I multiply what 2 parts of the triangle? The base, so called capital B, base, times height. And then we have to do what with that? Divided by 2. So multiply base times height and then divide by 2. Does that make sense? Okay, so I'm going to record this, and then I want you guys to open up your book to page 42 and look at some of those problems and try them.